Okay, so in this problem, I'm given that there's an elastic collision between two balls that are traveling in opposite directions. I'm given the mass of each and the initial velocities of each. And I'm asked to find the final velocity of the second ball after the collision. So the first thing that I'm going to do is I'm going to draw a picture to help me visualize this problem. So I have the first ball here. I'm given that the mass of mass 1, which I take to be ball 1, is 2 kilograms. So I'll write 2 kilograms here. I'm given that its initial velocity is 1 meters per second. So I'm going to define the right direction to be my positive direction. And you can really define any direction to be your positive or negative direction as long as you stay consistent throughout your problem. So I'll label this as 1 meters per second. Now the second ball, I'm given that it's 3 kilograms. And then I'm given that it's traveling at negative 2 meters per second. So since I've defined right to be my positive direction, that means my negative direction is going to be left. So I'll draw an arrow to the left here, and I'll label this as negative 2 meters per second. So, since I'm given that this is an elastic collision, that means that momentum and kinetic energy are conserved. And when those two conditions are met, we have an equation for a collision that makes this problem a lot simpler for us. So that equation is going to be velocity 2 final. Since we're being asked for the final velocity of the second ball, so that's mass 2, so we're looking for V2 final. It's going to be equal to 2 times mass 1, so the first ball, divided by mass 1 plus mass 2 times velocity 1 initial, so times the velocity of the first ball when it's first moving, plus mass 2 minus mass 1 divided by mass 1 plus mass 2 times velocity 2 initial, so the velocity of the second ball before the collision. So now all I need to do is plug in my numerical values for this and get an answer. So I have 2 times what's the mass of the first ball is 2 kilograms, and I'm just going to drop units here for a minute to make things simpler for us. Divided by mass 1 plus mass 2, so that's 2 plus 3. You notice that these are kilograms, it'll be kilograms in the numerator and kilograms in the denominator, so it cancels out anyways. Times velocity 1 initial, which is 1 meters per second, okay, plus mass 2 minus mass 1, so what is mass 2? That's 3 kilograms, minus mass 1, which is 2 kilograms, divided by mass 1 plus mass 2, so that's 3 plus 2 times velocity 2 initial. What's velocity 2 initial? It's negative 2 meters per second. Okay, so now let's just calculate this and find what it is. So we have 4 divided by 5 times 1, so I'll just leave that, plus 3 minus 2, which is 1, over 5, times negative 2. And that's just going to give me right here, is going to be a negative 2. Okay, so these have a common denominator, so I can just go ahead and add them. This gives me 2/5, and that's going to be meters per second. So the velocity of the second ball after the collision is going to be 2/5 meters per second to the right, because that's the positive direction that we've defined.